Hello, everyone. We are waiting 1 or 2 minutes just to be sure everyone is here, and we will start.
Okay, thank you.
Okay, so I think we are starting because we have a lot of things to discuss today, very interesting things. So welcome everyone to this webinar of the Circular Cities and Regions Initiative from the Knowledge Hub called Bio-Waste, Organics and Territorial Bioeconomy. So this webinar is coordinated by Cabeloce in collaboration with CETENMA and of course the best practices that will be also showcased. And my name is Noemi Garcia. I am a consultant at Cabeloce, and I am also a coordinator of CCRI Knowledge Hub. So first of all, I will please ask you to introduce yourself, so to have a sense of who is in the room. So since we are quite a few, I will please ask you to put it in the chat. We cannot open the mic, but you can put it in the chat. So your name, from which city you are joining, an institution, and so we can see a little bit who we are here today. And meanwhile, you write in the chat. I will go through the agenda. So I'll start with a quick introduction of the CCRI framework. And then we'll have an introductory presentation on the role of organic urban waste within territorial bioeconomy systems. So we'll have Miguel Ángel Suárez from CETENMA, who will provide an overview of the current framework, key technologies, and main challenges. Then we'll move to a series of case studies across Europe, showcasing different inspirational approaches on how to valorize the organic fraction of municipal waste. So these include experiences from Arezzo in Italy, Waste Up project in Valencia, Empower's nutrient recovery approach, and the circ-sized mobile biorefinery pilot in Finland. Then we'll have a short break, and we will continue with an interactive capacity building session led by my colleagues, Aran Blanco and Laura Pinzón from Cabeloce, where you will have the opportunity to reflect on the topics discussed and exchange ideas with the rest of us. And finally, we will wrap up the session around 12:51. So let's start with this overall framework of the Circular Cities and Regions Initiative, or CCRI. It's an innovative collaboration and support scheme of the European Commission, launched by DG Research and Innovation, and it's part of the European Circular Economy Action Plan 2020, and it is aligned with the main policy objectives and in sustainability of the Commission. It's supported by European Research and Innovation Funding Program, Horizon 2020 and Horizon Europe, with more than 250 million allocated. And its aim is to support circular systemic solutions in European cities and regions, as well as new circular businesses and governance models. So to date, 142 cities and regions have already participated in our program successfully. And the CCRI is also a very big network of associations. So it brings together more than 300 organizations to support circular economy principles. What's in for European cities and regions? What do we offer in the CCRI program? So there is a part of knowledge building. You can find all this in the CCRI website. And this is about funding guides, self-assessment tools, catalog of technologies, case studies, etc. We have also a part of exchange, including twinning programs, community of practice, etc. And we have a part as well of support, more tailored support through mentoring, financial assistance, and also capacity building activities. So these webinars, this is only one of the whole webinar series of the Knowledge Hub. I will remind the remaining ones at the end of the session. This is a part of this capacity building activity. Okay, so before continuing, just a couple of logistical details that I have forgot to mention before. The meeting will be recorded. So if you don't want to be recorded, please just turn off your camera. And the slide will be also shared, okay? Okay, without taking up any more of your time, I would like to hand over to our first speaker. So Miguel Ángel Suárez, project coordinator in Seterma, with his overview of urban biowaste management, composting biogas, and innovative valorisation pathways. Miguel, the floor is yours. I will stop sharing.
Thank you very much, Noemi, for the introduction. Thank you very much to the Circular Cities and Regions Initiative for having this opportunity to present and to introduce a topic that is actually something that is very common to all the cities and regions in Europe in the late years, which is the management of urban biowaste and the different possibilities that it has. So first, I will present myself. I'm Miguel Ángel Suárez. I'm a project coordinator in CETEMA, in the Technological Center for Energy and Environment in the region of Murcia, in southeast of Spain. We have experience in Horizon Europe projects coordinating as Valley Waste, Hoop, Fair Play, or now Empower, and we are working on different areas related with circular economy as valorization of waste, of soil health, of water treatment, so that we have a good overview of what is the starting point and what is the problematic with cities and regions, because actually that is one of our points and one of our customers, the cities and the regions. So I will start very briefly. First, I would like to just set the scope of the not only of the workshop, but also of my talk, that is the organic fraction of municipal waste. And first, we need to talk about the municipal waste. This is the one that is generated in the households, in Horeca sector, that is collected by the municipalities, and the management is in charge of the municipalities. Some numbers. These are from Eurostat in 2024. They were generated 222 million tons of municipal waste in the European Union, from which 67 they were bio-waste. What do we understand by bio-waste? This includes food waste from households, from Horeca sector, from institutions, that is similar to households, but also garden waste, prunings, and this kind of biological material that has some properties. But not only the 67 million tons, is that there are 47 million tons of mixed municipal waste, from which an important fraction is also an organic fraction. It's important to consider that since the beginning of 2024, it is compulsory to make separate collection of bio-waste in all the municipalities in Europe. So this is a hot topic for cities and regions around Europe. With the treatment, according to the statistics, 45 million tons are being composted or digested. That represents like a 20%, but there are still more than 100 million tons going to landfill. Here, there is something important to mention, is that in many places, especially in South Europe, many municipalities have what is called the mechanical biological treatment. This is taking the mixed municipal waste, separate it into different fractions, getting an organic fraction that is stabilized by composting. Since the beginning of next year, that stabilized material cannot be considered as recycling anymore because it's not coming from separate collection. So this is an important topic considering reaching the targets of recycling. So we talk about bio-waste, and then we start with the more conventional and the most widespread methods for valorization of this bio-waste. These are composting and anaerobic digestion. Roughly, both of them consist in the same: bacteria eating waste and generating something and transforming the waste. And of course, generating more bacteria. The kind of bacteria make the difference between the kind of treatment. In the case of composting, we have bacteria aerobic. This is the typical thing that is done, for instance, with windrows, with piles, so that it is generated a compost, a kind of soil amendment. This process of stabilization, biological, decreases the weight and the volume of the waste. Let's take into consideration also that the bio-waste has a very important amount of moisture. So there are changes in size here. And this is applicable for both to urban bio-waste, to household bio-waste, and to garden waste. Wood waste, it's not so compostable. It's something that is difficult to treat, but wood is necessary also to provide some structure to the final product, to the compost. Then there are different approaches and strategies for running the composting. We have the typical, the central plant, so that the municipality makes the separate collection, either with containers, either with bins, and go with a truck to a big facility, to a big composting facility with long holes and long piles to produce compost. This is one of the options, but there are others that are more atomized and probably more close to the producer and to the final user. For instance, the home composting, having small kits inside home to make compost from their own home waste. This is normally applied to households with garden that can use the compost themselves in their gardens. This same approach can be done in neighborhoods where there are several houses, so that they go to a common point, they add there all their bio-waste, and they prepare the compost that is taken by them in what is called community composting. There are different methods for doing this. Then, the product itself, called compost, is used as soil amendment. It provides a good organic matter to the soil. But it needs to be considered that only the compost done from separately collected bio-waste can be considered as compost. This means that the one made from the organic fraction separated in the mechanical biological treatment, that is not compost. That is called biostabilized material, and that is not considered for use. I say this because in the past it has been called compost to that, and that gave a pretty bad reputation to the word compost. Compost is included in the fertilizer product regulation, always considering that the composting process is done under certain conditions that provide good stabilization, good hygienization of the material. And sometimes one of the issues that are attributed to compost is the low value. Well, this depends. This depends because if the composting process is done in such a way that is targeted to increase the quality of the material rather than get rid of all the waste possible, then the value increases. And we had examples of that in Project Hub, for instance, with Porto. The second part is the biogas, the anaerobic digestion. In this case, the bacteria do not have air. The digestion is done in conditions where there is no air. This is a bit more complicated than the composting because it requires a facility, a digester where this pot starts making the different reactions so that at the end we finish with a biogas and with a slurry called digestate. It is important for anaerobic digestion to have bio-waste of high quality to avoid any kind of technical problems because besides this, there are different technology providers with different configurations, with different reactor designs, and it can be done depending on the moisture content on wet basis or dry basis. But that is a technological point of view. As I mentioned, this is more complex because it's a chain of reactions using different species of bacteria. First, there is a hydrolysis that they cut the structure into sugars, lipids, proteins. Then acetate is generated, then volatile fatty acids. And at the end, methanogenic bacteria transform the volatile fatty acids into methane. What is methane? That's the gas of the natural gas. So this means that the biogas is an output very important and very valuable in economic terms because it provides a source of energy, both from the plant and both considering a later upgrading. So here we must make a consideration, is that biogas is not biomethane, it's not the same. Biogas, it's a blend of methane, carbon dioxide, and another impurities, normally with very bad smell, like ammonia, sulfuric acid, and other kind of stuff that, of course, it is coming from garbage rotting. So this needs to be purified to be used in engines, or in the case of preparation of biomethane, the upgrading. That means removal of both the impurities and the carbon dioxide to have a gas that is equivalent to a natural gas, and that can be either used inside the factory or injected to the natural gas grid. Then the second point is the digestate, the rests that are remaining after the digestion with the slurry. This slurry is very rich in nitrogen and phosphorus, and as in the case of compost, is also included in fertilizer product regulation. This has more or less water depending on the technology, and it is possible to separate into a solid effluent, a solid fraction and a liquid fraction. The solid can be further stabilized by composting, and the liquid is very rich in nutrients, especially in ammonium, and it can be directly used as fertilizer, or it can be performed nutrient recovery to it. So this is a growing and expanded technology for bio-waste treatment. And just a data, in Europe, they were generated 25 million tons of digestate only on dry matter in 2024. Then we come to innovation because we have seen what are the two main methods for treatment of bio-waste. But this is like coming to a restaurant that we have just two dishes. Yes, they are very good, but they are just two. So in many cases, there is the desire to have a higher added value because both composting and anaerobic digestion might not be the top of the added value. So here is the point that made the origin of Hub, of Project Hub. That was how to get a higher added value from the urban bio-waste, because there have been a lot of projects researching about that, making pilots about that, but trying to deploy these solutions into a larger scale. So in Project Hub, it was done a portfolio, it was done an evaluation of a lot of technologies for valorization of urban biowaste into high added value products. You cannot see the deliverable, but you can see the derived publication that is available online and in open access. So these technologies mapped in Hub, they were like 25, they open new market sectors besides the fertilizer stuff. They were biostimulants, biopesticides, chemistry with chemical building blocks, nutrition with animal feed, cosmetics, biopolymers, construction, textiles even. So opening a lot the range and providing a whole set of solutions and combinations that could be done from urban biowaste, from sludge, and from others. We'll see some examples from Waste Up later. And from that whole set of technologies, we can classify and categorize. A huge group is hydrolysis. It's based on hydrolysis. Why? Because most of the food waste is based on fruits and vegetables. And fruits and vegetables have a lot of sugars and of fiber. But at the end, the fiber is made of sugars. So cutting the structure, the starch, the fiber, the different macromolecules inside the food waste leads to a solution, to a hydrolysate very rich in sugars. And this is gold for bacteria. This is gold for biotechnology to be used as growth media, because sometimes the growth media can be really, really expensive. So if we hydrolyze the biowaste, we open a whole range of possibilities for fermentations, for biofuels with bioethanol, for chemical building blocks like 2,3-butanediol, succinic acid, PHA, polylactic acid with biopolymers, for the growth of microbial biostimulants, biopesticides, microalgae, even for the production of recombinant enzymes. So it's opening to be a raw material for a whole sector of biotechnology. Another possibility, continuing with the soil application, is the thermal treatment. This is nothing new. I mean, it's pyrolysis, it's hydrothermal carbonization, but applied to material that is bio-waste, or in many cases wood waste, so that it is generated biochar and hydrochar that can be used for a soil amendment. The fibers can be also used and isolated for creating materials for construction, for isolation. And besides bacteria, fungi also like the organic matter. And so fungi are formed by fibers of mycelium that can be used for packaging, for construction material, and even for textiles, as for instance, vegan leather that are made from fungi. Other possibilities, as mentioned before, and what Vanessa will tell later, is the nutrient recovery from anaerobic digestion by streams. I mean, nutrient recovery, it can be done to the effluent of the digestate, so that it can be recovered phosphorus in form of estrubite, ammonium sulfate after ammonia stripping and scrubbing, and also by recovery with reverse osmosis membranes. This is actually a set of technologies that are also very well developed for manure with Renew. That is not urban bio-waste, but those technologies are getting a kind of maturity, and also other possibilities with biogas as single cell protein or microalgae. Other possibilities: stop the chain of reaction of anaerobic reactions in the volatile fatty acids to get the volatile fatty acids, biopolymers, or photobiotrophic bacteria. And also the waste, or better to say, the agri-food byproducts can be food for insects, for black soldier fly larvae or yellow mealworm. But we need to be careful here because there are regulatory restrictions depending on what's the final use of the larvae. Because at the end, this is husbandry, and they cannot eat whatever. But as any time that we are dealing with innovation, there are challenges, and these challenges are regulatory. So it's very important to run a regulatory feasibility analysis every time that you want to start a new project, especially in bioeconomy, because you might find closed doors, especially related with animal byproducts regulation, that at the end will end up in the 2 dishes of the menu. And now, as it is one of the targets of CCRI, it is very important for cities and regions know not only what is promoted by the public authorities, but also what is happening in the region from private initiatives. It's a good way to have an observation and a monitoring of the circular economy in the city and the region to find synergies. And this is a case study, the LUPA, or the Regional Observatory of Circular Economy in the region of Murcia, promoted by the region of Murcia and managed by CETEMMA, that provides, here you have the website, really interesting, that provides the framework and the meeting point between the authorities, between the entrepreneurs, between the companies, between the different stakeholders to capitalize all the research and all the initiatives in circular economy that are taking place in the region of Murcia, so that there is a synergy and a collaboration between the different actors in the region. Here you can have the different projects of the companies, big companies, small companies. There is a whole mapping of the projects, the initiatives, and this is, of course, also a good practice to inspire and to showcase to other cities and regions in Europe. I will provide two examples related with biowaste. One of them is this one for the production of single-cell protein from agri-food byproducts by fermentation. These are bacteria that are intended to be used by as animal feed. And a big one, this is for the production of biofuels from used cooking oils and food byproducts through some chemical processes so that they can be produced biofuels for the use in cars, vehicles, as substitutes of diesel. And last but not least, a good monitorization is essential to understand how well is going in a city, in a region, with all the good practices that are taking place, categorized by indicators, categorized by the sector, providing numbers, because at the end, what we cannot measure, we have no idea what it is. So this is a good way to have an observatory and provide feedback on what is going on in the region of Murcia, even with mapping in the map, each of them, so that this common point is promoting that everybody shares their initiatives, shares their projects there, and we can have a regional symbiosis and build circular systemic solutions. And of course, sustainability indicators, territorial indicators, that at the end, these are key to understand if the policies of circular economy are working. So thank you very much for your attention. And if there is any question, you can contact me, or you can contact any of my colleagues in CETEMMA, that we will be very pleased to answer your questions. Thank you very much.
Thank you very much, Miguel Angel, for this super interesting introduction to the topic, and there was a lot of information, also the Lupa use cases, super interesting. We will have the time for one or two burning questions if you have them, although we also have space for questions in the participative sessions. But if there is anyone who wants to do a question, we could address it. If not, we will just continue. So I will reshare the presentation. And we will start now with the case studies. So we are starting with Alessandro Forcioni, Director of Environment, Climate and Civil Protection Service for Arezzo City, who would speak about their project, Green Me 5, and in the city of Arezzo. The floor is yours, Alessandro. You are muted, Alessandro.
Sorry, I already lost some of the time assigned, so I will try to stay within it. In my speech, I won't focus especially on bio-waste, but on the general path that led us to our goal to redraw generally the collection system and treatment system of waste in the city of Arezzo. Even if organic, as we just saw, is a very important share because of its weight. It's almost 30%. Because of its peculiarity, it can represent even hygienic problems within the city and its value. So this was the starting point. Arezzo is a city close to Florence in central Italy, and the municipality itself has a large territory. It's 384 square kilometers, around 100,000 inhabitants, an important industrial reality, a complex territory made of hills, made of country plains, and many scattered houses, and an important touristic presence with very concentrated peaks, especially in the weekends during the autumn season, okay? So previously, and I'm speaking about just before the COVID, 2019, 2020, the waste collection was centered on unsorted waste, patchy and disorganized service. We couldn't reach all the territory and all the houses, very old bins, and no room, essentially. I don't know, I had two images under these lines, but I can see them, but I can tell them. The picture just showed what I just told, old bins. We had very scattered sites for street collection of waste, essentially based on unsorted waste. So you could find, for example, 3 bins for the unsorted of 3 cubic meters, each one of them, and just one small bin of 200 liters for the organic fraction. So the message is clear, no, give me unsorted. That was the message for the citizens. And in the city center where we couldn't put the bins, there was simply no rule. So whoever could dispose their waste when they need it, where they need it, in the way they need it. And continuously, the manager, the company, passed through the streets to collect those wastes. The production total was very high, with 650 kilograms per person per year, and separate collection under 40%. That's year 2019. Please, next slide. Oh, you see the images. Okay, so on the left, that's the situation of the historical, no problem. The historical center of Arezzo, you see, no rules, and a lot of sacks. And on the right, you can see maybe, oh, sorry, can you go back? On the right, you can see maybe the best site for street collection. because that it's almost complete. At least you had cardboard and paper, you had plastic and metals, and you can see the last 4 ones are for generic waste, unsorted waste, and a very small brown bin for the organic. That's the previous situation. Please go ahead. So what we did in a span of 6 years, in the last 6 years. So we started from the plant. In Arezzo, there is a big plant, which belongs to a public company, and the share of the city of Arezzo is 86%. So we are the owners of that plant. So, but before we had only an incinerator and, well, a waste to energy plant, and we decided to invest in a digester and a compost plant for a total of 35 kilotons per year that go through the digester, and the 70 kilotons to the compost plant. All the digestate goes to the compost after digesting, okay? Then a new design for the collection system, new and complete bins for the city. So that means that every site has the same amount of bins for every fraction, and door to door on the open territory for the scattered houses and small towns around the city. And especially, this is very important, dedicated services for non-domestic users, because many non-domestic users, from shops to bars to restaurants to factories, have large production of urban waste. And it's impossible to manage for example, in a bar, they produce a lot of powder from coffee. It's impossible to manage it with door-to-door collection with a traditional service for the citizens. So we gave every non-domestic user special services, maybe once per day, maybe twice per week, different, tailored on their needs, okay? Then deep communications, letters to users. We made dozens of public meetings to inform, a punctual verification of particular situation. So you cannot think to make a project and blanket the project on the whole territory. You have to analyze the needs, the problems of each part of the territory, and tailor special solutions and validate the general solution. Then we put incentives for separate collection. We have 2 collection centers. So for every kind of waste a citizen put into the collection center outside the city, he gets points that gives him discounts on the tax for the next year. And we decided to give for free to citizens composters. We have more than 2,000 families in Arezzo that compost their organic fraction. And we can estimate around 1,400 tons of waste not produced every year. And remember that when you collect organic, you transport water, you treat water, and if you dispose in landfill, you dispose water. So that means costs. And then finally, controls and sanctions. Okay, please go ahead. These are the results. The data are just in time. We reached the 70% of separate collection last month in May 26, and Arezzo invested a lot in this transformation, but we are still the city in Tuscany that pays less for the collection and treatment of waste. The data refers to 2024 because we still don't have the 25 still certified, but the trend is this one. Please go ahead. Lesson learned. Okay. The services should be spread, coherent, accessible, and universal. This is because This is the only public service where the user is the primary actor. If the primary actor, which is the citizen, don't share your goals, you won't get to your goals because separate collections start within the houses. So every citizen should be provided with service which are close by, accessible, and universal for all, okay? And for all the fractions. Services oriented to final user. Last mile design. Well, that's what I told before. You cannot think to make a general project and you blanket the project on the territory and then, wow, it's done. No, it's not this way. Because once you put on the field your project, you have to adjust many situations. And to do so, you have to exit your office, verify, find the best solution, maybe sometimes, when possible, together with the users, and then you transform, even on the go, your project, your initial project. Then the importance of communication, because if the citizen don't share your goals, you won't get goals. And results need time. You saw in the graphic before that we are still growing up, but we finished the transformation in May 2025. So we are still collecting the results. Don't think that you will see the results after 2 months after the changes, okay? And then, very important, maybe the most important, the collection is driven by plans. If you don't have plans in your territory, don't expect to have results because the costs will rise, because the plans that you have on the territory will drive the collection. We were at 40% because for 20 years we had the waste to energy plant in the territory. So we invested on the digestion, we invested on the composting, and the next step will to invest in a matter farm, matter factory, so to recover plastic, glass, and metals. Please go ahead. This is the reason why Aritz is here, because as you mentioned, we participate in a European project which is called Greenify, together with the city of Murcia, with the Federation of Municipalities of Murcia, the region of Murcia, together with Vilnius, Helsingborg, and Eurovertice. The project gives support to the cities to advance towards the goals of the Green City Accord, and gives us the resource for a pilot action. And our pilot action, you can see on the left, the inauguration day, is to put within the city, this especially in the area occupied by the weekly markets, bins for precious materials such as the electronic and electric waste. And we are having good results, not only for the waste, but for example, for the PET, for the bottles, plastic bottles collection. And we have even a water house that provides water to citizens. And we are thinking about to replicate this experience in other parts of the city. And the region Tuscany is giving us the money to experiment and to extend this experience. And go ahead. Oh, I'm finished in exactly, oh, wow, 12 minutes. I'm so sorry. I took 5 minutes more, and I hope
No
that
worries.
was interesting.
No worries, Alessandro. It was worthy. Thank you very much for these insights. I know it's a very big challenge that we are asking to the speakers to summarize in only 6 minutes a whole project or a whole initiative. So, well, please, we please ask you to try to do it so we can cover everything we had planned for this webinar. But yeah, we understand it's hard. So, is there any question for Alessandro? Although, as I say, he will also stay, right, to the participative session, so there will be also space to ask him anything in this section. Okay, then we will continue with the second case study. So this is Waste Up. So lessons from the Valencia pilot by Belén Miranda, project coordinator at Agricultores de la Vega de Valencia. Belén, I hand it to you.
Hello everyone. Thank you very much for the introduction. And I would like to say thank you also to CETEMA team and Queveloce team for inviting me to this webinar. Thank you very much and give me the opportunity to share the work of OISTAP project and to learn more about this interesting topic. So let's start with the presentation. I would like to present today the Valencia pilot developed in the Horizon 2020 project, in WasteUp project. So to give some context, Europe produces millions of tons of organic waste, as everyone knows, every year from households, restaurants, markets, and the food industry. So traditionally, a large part of this waste was being composted or incinerated or sent to landfill. And however, these materials still contain valuable resources that can be recovered. So for that, WasteUp was created to demonstrate that the urban bio-waste should not be considered waste, but a valuable raw material from producing new bio-waste products. So the project, therefore, I mean to answer some important question, which is how can cities transform urban bio-waste into valuable products while supporting the transition toward a circular bioeconomy? Next, please. Well, to understand the project, it is important to understand why WasteUp was created, and three main factors come together. First, the European circular economy strategy, which encourages keeping resources in use for as long as possible instead to treating them as waste. Second, the bioeconomy strategy, which promotes the sustainable use of biological resources to create new products while protecting the environment. And third, the continuous growing of urban bio-waste. Everyday cities generate large amounts of organic waste from households or restaurants or markets. And these three factors that I tell you created an important challenge. Cities were facing high waste management costs, valuable resources were being lost, and value chains were fragmented, regulations were often complex, and public participation in separate collection was still limited. So for that, WasteUp was created to address these challenges. The main goal was to transform urban bio-waste from a waste management problem into a valuable local resource, supporting the transition toward the circular economy. Next slide, please. Well, after understanding why the project was created, this slide shows how WasteUp works. The project starts with different types of urban bio-waste, such as food waste, coffee grounds, used cooking oil, fish and meat byproducts, green waste, and sewage sludge. And these streams are processed using innovative biotechnologies and valorisation processes, allowing valuable materials to be recovered instead of being discarded. So as a result, the project produces a wide range of bio-based products, including bioplastics, bioethanol, biosolvents, biochar, proteins for feed, bioactive compounds, and a kind of fertilizers or another biomaterials. Well, but the project goes beyond producing new products. It also creates new local value chains and generates business and employment opportunities and reduce the greenhouses emissions. Next, please. Well, to achieve these ambitious objectives, Waste brought together 26 partners from different European countries. Each organization contributed different expertise. Some partners were responsible for waste collections, others developing the processing technologies, while others evaluated environmental impacts and market opportunities and communication activities. So SAP, the Agricultores de la Vega de Valencia, was the coordinator of the project and the coordinator of the Valencia pilot, working together with several partners, demonstrating innovative processes using local urban biowaste, because the company is dedicated to the whole processing of waste management and water treatment plants. So it's our main activity. Well, next slide, please. The Valencia pilot, this slide shows how the main value chains demonstrated in the Valencia pilot. The first feedstock was fish and meat byproducts. These materials were processed through enzymatic extraction and hydrolysis to produce gelatin, hydrolysis collagen, and bioactive peptides, which have application in different industries. The second feedstock was spent coffee grounds. Through the extraction of valuable compounds, we recovered coffee oil, polyphenols, and carotenoids, giving a second life to this common urban waste. And the third feedstock was used cooking oil. Using biotechnological conversion, it was transformed into PHA, bioplastics, and long-chain decarboxylic acid. Well, next slide, please. Yes, the main achievements, the Valencia pilot achieved important results in three main areas: technological, environmental, and societal. The first one, from the technical perspective, the project successfully demonstrated several circular value chains. The technologies were validated at pilot scale, and so that urban biowaste can be transformed into high value biowaste products. Sorry. And from the environmental perspective, the project helped to reduce the waste disposal by recovering valuable resources that would otherwise be lost. And finally, from the societal perspective, we start increasing citizen engagement and awareness about the value of urban biowaste. Next slide, please. Regarding lessons learned, the project, after 4 years of work, the project identifies several important lessons. The first lesson is that collection quality is the key. High quality bioproducts start with high quality separately collected biowaste. Reducing contamination is essential for successful valorization. This was a very important lesson learned. The second one was the collaboration creates value. That means that municipalities, waste managers, industry, researchers, and citizens all have an important role. No single actor can build a circular bioeconomy alone. It is very, very difficult. And the third lesson is that the technology is no longer the main barrier. That means that the technologies have already proven to work. Today, the biggest challenges are logistics, reliable feedstock supply, industrial scale-up, and market uptake, related all of these things. The fourth lesson is that regulation needs to evolve, clearer and more harmonized rules, especially for end of waste criteria. Permitting will help innovative solutions reach to the market faster. And finishing, the fifth lesson is that the citizens are essential partners. Better participation improves waste separation, which is very, very important. Increases collection quality. Wood separation increases collection quality and helps people access products made from urban biowaste. That's at the end, and they will be the end user. So this point is very, very important as well. Finally, the main message from Waste Hub is that technology alone is not enough. A successful circular bioeconomy requires an integrated ecosystem where technology, collaboration, regulation, and citizen engagement all work together. Next. Well, that's all from my part. Thank you very much for your attention. And if anyone has any question, I'm happy to answer, of course. Thank you.
Thanks a lot, Belén. So is there any question? Because I think Belén is not able to stay to the last part. So if you have any question, please make it now. Otherwise, thanks again, Belén, and we can pass to the next study, which is Empower. So a topic which we have identified as an important one for the cities we are mentoring. So how to turn organic waste into biogas and fertilizer through nutrient extraction. Vanessa Nogales from Lambert Europa. The floor is yours.
Good morning, everyone. My name is Vanessa Nogales from Lambert Europa, and today I will present our case study within the project Empower. The starting point is the nutrient challenge in Europe. Today, nitrogen and phosphorus flows are still largely linear. Europe exceeds critical ecological boundaries for nitrogen and phosphorus emissions, creating a strong environmental pressure. This leads to eutrophication risk in aquatic ecosystems, high environmental and health costs, and underuse of organic waste streams that are often managed through low-value pathways. For us, this represents both a challenge and an opportunity to recover nutrients from organic waste and return them to agriculture in a safer and more efficient way. In Empower, Lambert Europa leads Task 3.1 and operates a pilot technology in Murcia. Our pilot demonstrates and integrates a biorefinery concept. The system processes local agriculture and livestock waste through anaerobic digestion, mechanical separation, and nutrient recovery strategies. The objective is clear, is to obtain three main outputs. The first is a biogas, which can offset fossil energy use. The second, a liquid digestate-based fertilizer called RF1. And third, a solid digestate-based granulate compost called RF2. The key point is that we are not only treating waste, we are converting it into useful products with agronomic value. The expected results are mainly technical, agronomic, and environmental. From the agronomic side, we will validate the two fertilizer product through field trials. From the process side, we optimize nutrient circularity and improve the biological absorption of nutrients. Safety and regulatory compliance are also essential because recovered fertilizers must meet strict quality standards before they can be used in agriculture. Finally, the pilot will generate empirical data to support regional nitrogen and phosphorus budget, while reducing greenhouse gas emissions compared with conventional management routes. Falta una diapositiva.
Okay. Sorry, I will look for it.
Barriers and mitigation.
No. This slide, we asked it only for support for the last,
Okay.
for the last part, for the,
It's true, it's true.
the participative session.
Sorry.
No worries. Okay. Thank you, Vanessa. So that would be it. Yeah, from now.
Yes.
Okay, perfect. So thank you very much. In the case of Vanessa, you will stay, right, in the participative session as well?
Yes.
Okay,
Yes.
Thank you very much. So then questions can be addressed later on. And we have the last case. We are very sorry, but we think the break we won't be able to do it. So we will just do this case of Finland, and then we will continue with the participative session. So this case study is about a project, Demo5 project in this city. I'm not going to try to pronounce the name, it's too hard, but I leave it to Mirja Kontro, Associate Professor at University of Helsinki. Mirja, the floor is yours.
Okay, thank you very much, and thank you for inviting me to give a presentation. I'm very pleased to do that. Next slide, please. So in this circular systemic solution European Union Horizon project, we are developing polyhydroxyalkanite production. And background is that there are many waste materials, sewage sludge, forestry waste residues, so separated bio-waste, agricultural waste, and so on, where there's a lot of organic matter, and uncontrolled recycling of these materials leads to greenhouse gas production, so we must recover carbon. And these polyhydroxyalkanides are bacterial storage lipids suitable for biodegradable compostable plastic raw materials. And they are interesting, therefore, that in this way, when we recycle organic materials to PHA production, it means also that we are able to produce plastics with renewable carbon sources, and we avoid then using fossil raw materials. Next slide, please. And generally the most common process for PHA production is this feast and famine, which includes aerobic and anaerobic stages, which are alternating. And then it leads to a reaching PHA up to 50 to 70%. But then when we began this, we observed already in early stages that feast and famine does not really work with sludges where phosphorus is precipitated by ferrous sulfate. So it's difficult to get to function. We tried it many times. And then we realized what is the reason. Ferrous sulfate precipitated phosphorus is solubilized under anaerobic conditions. And then the other bacteria are able to overgrow those accumulating bacteria so that it's difficult to get to function. And then we developed a new approach where these polyhydroxyalkanides are accumulated by fully aerobic, under aerobic conditions, and then we use phosphorus limitation. And this method has been now patented from the University of Helsinki. So when we have, for example, phased hydrolysis here, you can see, then we first hydrolyze it. And this hydrolysis means that there is hydrolysis and acetogenesis, but then no more, because we do not want to produce biogas. And to prevent that biogas production, we use low aerobic conditions, but very low, because if we have high aerobic conditions, then volatile fatty acids are consumed as carbon source. So, but our vessels are open. We do not use completely closed vessels, which reduces the overall production costs. And then after hydrolysis, we separate liquid where the volatile fatty acids are. And during hydrolysis, phosphorus is also solubilized, and then we precipitate phosphorus to remove that phosphorus. And this is a step where actually phosphorus can be recovered from wastewater. And then these volatile fatty acids are fed first to enrichment bioreactor, which then those bacteria continue to accumulate PHA. And at the end, PHA will be extracted, and then those granules can be formed. So next slide, please. And we are now going in such stage that these small pilot scale bioreactors have been developed. So we use completely this right side vessel is the hydrolysis. There's a very slow mixing, and then we get from wastewater sludge, and also, so wastewater sludge we get about 10 grams per liter of volatile fatty acids. And one challenge in utilizing these different carbon sources is that there are many difficult to digest materials like lignocellulose, hair in wastewater, and all possible fractions, and they belong to difficult to digest materials, so that's something we are focusing also a little bit to get all possible carbon sources to utilize. And then this PHA accumulation occurs under fully aerobic conditions, and volatile fatty acids needs to be fed daily, so we need quite much hydrolyzed biomass. And then we need to feed periodically also nutrients for those bacteria to be able to grow and enrich. And so we have been developing this system now in small pilot scale, 5 to 40, and now we are just beginning to increase scale to 400 to 1,000 liters. And then the main issue here is also to develop as easy process as possible to maintain system economical and all. And you see that this right side figure on hydrolysis vessel, it's very simple and cheap system. So next slide, please. And during this process, we have been, so in practice, initial aim was to optimize process in large pilot scale, but it's much easier to do in small pilot scale, for example, also hygienic problems due to hazardous microorganisms. And then when we use mixed microbial technology, it's a challenge always. There must be a selected pressure for correct bacteria. So it's the phosphorus limitation and carbon in excess in case of PHA accumulation. And then we have those drawbacks have been that when we used ferrous sulfate for phosphorus precipitation, we added also sulfate, and then sulfate reducing bacteria may be enriched. So it's better to use ferrous chlorine here for phosphorus precipitation. And then I said already that this biogas production in hydrolysis can be prevented by using non-gas tight containers, so that there's a little bit aerobic conditions sometimes. Bacteria consume quite fast those available oxygen, so that it's in practice it is anaerobic, but then when there comes periodically a little bit oxygen, then it prevents that biogas production. So that so it means that developing this kind of process requires strong microbiological, biochemical, and process expertise to understand these different alternative pathways for carbon, so that the other should be prevented, and this one that we want to pass further must be enhanced to get the correct product. Next slide, please. Then it's the next one. Thank you.
Thank you very much, Mirja. Is there any question? Okay. Again, I think Mirja also stays in the next part. So, well, I thank you all the speakers so far. Thanks so much for providing these inspirational examples and all these insights based on practical experience. So now what we propose, it's a more participative part where we want people to intervene and to basically think on how to implement all these solutions, or maybe they have already started and they can reflect on this. So thinking of the barriers and the enablers when trying to implement these kind of solutions in their territory. So I really encourage you to stay here. We have we have prepared this board in Miro, so please, you can click in my screen directly into this board, purple board, and you will go to the Miro board, or you can also go through the link. If my colleagues can put it in the chat, thank you. And you can go to Miro board. And I will leave the floor to my colleague, Aran, who will facilitate this activity.
Hello, thank you very much, Noemi. Okay, you will see I have now 8 people in the Miro board. So while the people is entering the Miro board, I will try to share my screen, which is here. Can you see my screen already?
Yes.
Okay. So far I have 8 people there and we are waiting for the other people to join, and I will explain a little bit what is the dynamic. So in the first 10 minutes, 10 to 15 minutes, we will start revising the challenges you have to implement biowaste solutions in your city or region, which can be 4 type of challenge. We have simplified to 4: legal and politics related to governance and regulation. Then we have the economic challenges. Then we have which can be the funding, for instance, for this kind of initiative. The social, which can be reluctance or can be educational issues, and technological barriers to applicate or to apply this circular economy in your territory, in your region or your city. For that, you only have to click on the stickies that you have here in the middle, to drag it, as I have done for this part, to the section you want to put the barrier, and then write on it. And then in the second 10 minutes, we will do the same, but with the enablers, also the solutions that we have found. I will put it a little bit bigger so you can see it, and we will focus first on this part.
And also, if I may, it's also a good opportunity to ask a question, any question you may have had in the previous presentations. It's the moment as well, because we will have all the speakers, almost all here present as well.
Yes, if you have any barrier and you want to ask our speakers how they have solved this challenge, this is also a good opportunity to ask them, because maybe they can provide you with any specific solution, with a concrete solution. You can raise your hand or in the peer or in the chat, whatever you feel more comfortable with. I see you are being quite active. Really, I like it.
I will make the post-its a bit smaller, okay, so we can
Yes, this is a good idea because
have
there is no more.
more.
I can help you. This is not blocked. I will put it a little bit bigger, Noemi, because I cannot even read it. Okay. Some of you have already started with enablers. You are very quickly. Put it bigger because if not, we don't see what we are seeing. Okay, a couple of minutes more for this part. And at the end, after we have the solutions and the enablers, we will have some minutes to synthesize all the activity, and we can take that moment to discuss or to maybe our speakers can see and solve any of the difficulties or the challenge that you have. So maybe you can address any. Okay, Vanessa, don't worry. If any question arises that is addressed specifically for you, we will email you, of course. Thank you very much. Okay, I still see you very active today in this part. This leaves keeps is still open. Just for time, I will go to the enablers part, so we can start working here, and you can still work. You can still add your posit to the other part, and when we summarize at the end, we will discuss them too. So you have 10 minutes to put here your posits. I am surprised I still don't see any in technology after all the technologies we have discussed today. Ah, yes, thank you, whoever. We are enriching it. So far, the more enablers are the social ones. And for the case of legal and politics, which is also important for you cities and regions, we have seen many barriers and not so many solutions, which is also related with the competencies, of course, that may be at a higher level. Just a kind reminder that you can ask or speakers that are here, thankfully. I would like to ask who has written here learnings GP from another city. What does GP mean? What do you mean with? You can put in the chat if you want.
I guess
So-
good practices. It's not me to have written that, but I guess it's good practices.
Good practices. I will put it full. So it is clear later when we have to discuss. This I will put a little bit bigger. If I can. I cannot. Okay, 5 minutes more. Thank you very much, Alessandro, by the way, for cleaning this. I didn't see nothing. Okay, a couple of minutes more. Do you have any other suggestion or idea? Although it is normal that we have more barriers than solutions because we are here to learn. Less than a minute. 2. Okay, we will go now to discuss all as a whole, all together. So, among the challenges that what we have, we will go part by part. So, the legal and politics, you have, I think that all the barriers in legal and politics are, we will put them together because there are a lot of them that they are related. Because there are no regulation, there is a lack of regulation, of clear regulations and regulatory frameworks that define ways that regulate their use, the characteristics of these ways to be used by the industry, like to create a database of this is the ways we generate here, this is the characteristics that are required, that or even the pollutant limits and that kind of issues that to be used. Also, you see a problem or a barrier that is not exactly waste, but is related to waste because it is the legislation of water infrastructure. So, because when we have waste management, some waste or some pollutants can get to the water too, and let's say we cannot use this wastewater or this for other things because this parallel legislation is even more and more tightened. Also, we have a lack or development of the lab about the biogas plants, which would be also needed, not only for the waste, but also for the biogas and how to put them in value. And finally, we're pretty bigger. We have constant changes in waste regulations that for the municipalities create uncertainty and make long-term planning of biowaste solutions more difficult. Because you have always for the cities that are let's say, the lowest administrative part is who has to fulfill all the requirements of regional, national, EU, and it is when you get used to one, then they change. Okay, for the economic, we have the funding and financing options that are targeted and to composting. Also to the dispersed territorial profiles in some cases. I think this is related with what Alexandro has mentioned before. Also, there is a challenge establishing intermunicipal association between different municipalities that could reduce the cost. And we have to remember this because there are already good practices on this, I think, in Portugal. And I think Miguel Angel in a previous project has experimented that and has studied that. How energetically, this is the energy consumption of the innovative solution, let's say for protein extraction or the obtention of these PHA, these bioplastics that can be very energy consuming too, and also a more territorial problem or issue is the door-to-door collection and the local composting that can be very costly for small or dispersed municipalities. That's quite right. So here we have the social issues, that we have the acceptability of the final products by the stakeholders, let's say the farmers, for instance, dig estate or compost. Also, we have from the low public awareness and the poor waste separation habits, which is more related to the quality sometimes of this waste that has to be treated, that because the effectiveness is reduced. We have also a problem with other issues from plants. It is understood that it's biogas plants, and yes, we have an NIMBY problems in many regions, not in my backyard, because, okay, we all want this to be valued or recycled, but oh, we don't want the plant beside our house. Then we have the challenge of enhancing civic engagement for the collection, to have the correct characteristics, and to have educational approaches. And in this case, Alexandro has had thought, I think, in Arexo had like solutions for that, and maybe he can speak about that later. We have the lack of staff, that the education pathways to manage this waste, not the high level, I mean, because people in university, but for the waste management plant itself or for the waste management service in the municipality, that maybe have not this level or of capacities or the public opposition to biogas plants. I will put it here because it is the same than we have mentioned before, and to adapt the population to circular economy challenges, which are a lot, not only the collection, but also to accept the, let's put it here maybe, because they are all related. They are the population, the stakeholders in general, and then we go to the technology. That the problem is that many of the technologies are in low in the laboratory level, but they need to be scaled. That for that they need to have pilots to optimize the processes. This is in middle from technology and the economic, because the increase in this scale can be a problem in terms of funding. Also, the uneven treatment, the uneven access of treatment capacity for above all for maybe for these small municipalities, which is related to this lack of facilities, and also the infrastructure to create the final products, because you need these plants to be bigger and with more equipment. Okay, let's go for the enablers, because this is always more interesting for me. The solutions. Okay, about the legal and politics, the municipalities are really committed to this circular circular economy transition, because it can be agriculture, but here we are also talking in the urban side, so circular economy transition. They are also in development fertilizer products, also regulatory framework for these products, and there is an increasing alignment with EU and regional and national regulations in this side, We have the framework from the EU, and the states and then the regions have to adapt the regulation to that. For the part of economic, we have many funding instruments, not only for research but also for SMEs, such as the single market program. We have a customer, we have potential customer. We have mentioned here the agriculture because the compost is often used in that, but we can also think on the gardens in the city. Not only if we are not, because agriculture for a rural region, okay, like Murcia, we have a lot of agriculture, but if we are in a more urban context, this can be used in gardens too. The public funding, I will put here too. I will put here the public funding together because the shared service, and this is something we spoke before, isn't it, Miguel Angel, that we have communities of municipalities that join together. Like, let's say the example of here we had in the past, I think in Murcia, in some regions of Portugal, also the Hub project have an example of many cities, small cities that join together to have to share this infrastructure. And in Catalonia, we have also the Maresme, who had joined many small cities to share this infrastructure so they can reduce cost and improve the viability of the solution in an economic point of view. We have also the clear ROI, the clear return on investment with benefits for the stakeholders, thanks also to this business model that can be created. And this is also related to the industrial synergies, which is also an economic opportunity to reduce the cost, because one industry or one service can use this waste, this high added value waste from initiatives like Waste Up to reduce their cost in raw materials. Okay, regarding the social, there is something that you share, some of you had just interrupt or ask here because I am going very quickly, not to lose the time, but okay, we have in the social, you have highlighted the interest of the stakeholders for final products that can create demand. This is related to these business models that we have spoken before, for the compost, for the estate, for animal feeds. Also the localized supply chains that can bring communities closer. This is also joined to a positive, in general, a positive attitude to circular economy in general. Also, we have here a slightly contradictory social, because we have awareness campaigns, because we still, for some sectors, okay, in general, there is a positive attitude, but we need still to reinforce awareness campaigns and citizen engagement and clear separation guidelines that can increase participation and improve the quality of organic waste. Let's say we make a compost, you know that some of the waste is not adequate, the bones, animal oils, and people, okay, organic. Everything organic goes there, but it is not the case, and that has to be very clear for the people. And we have also the learnings and good practices from another cities. And I had to say here that this is a very, very important role, and you will find many resources in the projects, in the CCRI projects, because you will find resources and a part of the best practices that we have today. And thank you very much for the speakers, because you have given some examples. We have many other examples from another cities. And finally, this technological, Belén said before that it is the technological may no longer be a barrier because we have many technological solutions right now from research projects. So we can take a look to them, we can see how they are used, because there is a wide variety. We have composting plants, we have anaerobic digestion facilities, we have smart bins that are used at the city level for the citizens, and we have also data monitoring system that can tell us how efficient is what we are doing, and to monitor and to evaluate and to constantly improve what we are doing in waste management. And also we have advanced training for technology operators that are more and more, let's say, in vocational education programs, university, higher education. There are always more pathways focused on circular economy. Okay. If anyone has any question, I give the floor back to you, maybe, to help me to see if there is any question here. Maybe I can start if anyone has a question. Okay. And I will ask my question is for the demo in Finland. And the question was okay, was related precisely to these barriers for scaling the BHA, because I know this and other projects related to BHA, and if they have what are the barriers for scaling, what are the solutions they are thinking for scaling, because I see that you have the technology patented by Finland University, but maybe you can clear us how are you dealing with these barriers?
Okay, I could say that for these piloting experiments, we have had quite a nicely budget. We have this EU Horizon project, and we have also had one European Regional Development Fund project, and we have another ongoing, which have been, we are very grateful to be able to, so that we have got these fundings. And now when we will do this piloting in a larger scale, we had problems because the legislation or wastewater treatment or generally water treatment has been tightened in the beginning of this year, and we were not able to do piloting in wastewater treatment facilities. But now we have got collaboration with Stora Enso, which is also located in Päijät-Häme region, and we will be able to do it's a company-owned wastewater treatment place, and we are able to continue this piloting in their facilities. And it's great because Stora Enso is one of those large forest companies in Finland, and actually Finland, more than 70% of landscape in Finland is covered by forest, so that it's an important industrial sector. So that still I think if we are able to increase scale to full scale, there will be discussion about funding, how to do it, so that it will be challenging.
So regional development funding also, this is something that we could add here as a positive, because if we have regions and municipalities, they are precisely not the focus of that kind of funds. We have mentioned here the single market program, but maybe we can add this regional development that can be a solution. Thank you very much, Merja. Thank you very much for your answer. Any other question? I will add it here, taking the opportunity. Tommaso, go ahead, please. You can write it here. You can write and I will say aloud. Don't worry. Write it here and we redirect the question to the expert. Okay, while Tomás, if any other people is wanting to ask anything.
Well, meanwhile, Thomas will write his question. I also had a kind of question about this. Also, these posts that have been put about not in my backyard or about this social uptake. Sometimes hard because it's something that's actually happening in my region. So people are not favorable to the installation of a biomethane plant in there. So because they are complaining about environmental impact, bad odors, also what it has been written, and maybe the possibility to have more farms in the zone, which again, worst environmental impact. So I don't know if any of the speakers have a comment or something about this, or how we could maybe improve that, or if you think there are complaints who are like, let's say, validated or. So yeah, Alessandro?
Yes, because we actually had that problem. Because, you know, composting can create other problems, not only from the plant itself, but even from the transport, because the trucks smell. And especially they do in this climate changing periods we are living, with 45 degrees under the sun. Organic waste smell within the bins, smell during transport, and sometimes it smells during the process, which is, yes, it's controlled, but you can't control it 100%. So this is an open challenge. I don't know, I'm not technical, I'm not a manager of the plant, but I have no solution to prevent 100% the other problem, but it's important at the same time to manage the situation when it happens. In Arezzo, we made a monitoring campaign through a codified system, which is it's codified through a UNI norm, which is an odor field inspection that gives you objective data about the frequency of the odor. And you can correlate it. We don't have a specific law in Italy for odors, but we compared it to the German regulation. So we could state where are the affected areas and the frequency of the problem, and where the problems stays above the threshold, the limits that you establish. Not low limits, because as I told you, we don't have low limits for odors so far. And in this case, if you cannot prevent the problem, at least you can manage the population, again, through communication, through information. The municipality knows what it happens and the entity of the problem. This is one first step, if not the solution.
Thank you.
Thank you. Okay, I am going. I don't know if Merja has an answer for the same question or.
Yes, I
that?
could say
Yeah.
just a few words about that smell problem in composting. So we are in Finland using biobeds through which air is conducted in composting halls. And then the other aspect is that composting windows outdoor are always a little bit hygienic problem, so that if you build the system closed, it reduces both smells and hygienic problems. So this, I know that it becomes biogas production has much less smell problems because it must be close to the biogas leakage problems, so that those two issues will help a lot in smell. It becomes more expensive, but it's good to consider. Okay, thank you.
Thank you, Merja. I will go now with the question from Tommaso because he would like to have an insight into the acceptability of the final product, the compost or the biodigestate by the farmers. For instance, here in Murcia, so I guess this is for you, Miguel Ángel. If the agricultural sector is accepting the products for their cultivation, the compost specifically, because he knows several places where the farmers do not accept, mostly because it has plastics or pollutants, not good quality.
Well, actually, it's a bit coming back to my presentation, is that the lack of acceptability is related with the times where the quality standards for compost were not so great. So they were appearing rests of plastics, rests of glass. So for those, the farmers didn't like. So here it's more than more than the acceptability of the product itself is to identify and sell a bioproduct that has quality, because if the bioproduct has quality, then it should be no problem. I can give an example from Project Hub, and related with one of the participants, Lipor, in the area of Porto, and they were working a lot, making a compost of a very, very high quality, and they had no problem of marketability. Actually, that compost worked pretty well with the vineyards in that area and it was really appreciated. At the end, the acceptability also has to do with the quality. With the digestate in Murcia, there is still not so much issue because there are not so many anaerobic digestion plants, but there are several in plan, and we will see the acceptability in the future. But we need to remember that this is also some outcomes coming from Project Empower, that there are a lot of tons of pig manure that by the moment they are not being treated so far. So it's finding the balance between the treatment and the manure that it's going to be there anyway.
Yeah, because we have this problem, the same problem that Noemi has mentioned before. We have here in Murcia, and we have a lot of opposition. There are plants that they're being constructed now and plants that are planned to be built in the following years. And we have had also a lot of opposition from environmental and neighborhood association regarding that problem.
And something else, Sarah, that I would like to add is that
of course,
when manure is applied to soil, we have the issue, the same issue, and you can smell ammonia in the air. I can tell you.
Yeah, I have friends living in Fuente Álamo, which is one of the main towns here in Murcia affected by that problem because all the pig farms are Lorca, Fuente Álamo, this part of the region, and I have to say that even in that case. My friends living there, I think there are already practices of biogas plants in that part, and they are saying, yes, I agree with, like, this is to agree with Miguel Ángel has said, yes, maybe the the biogas plant smells, and you have cleared it before, very good, very in a fine way, because this is not the problem of biomethane, but it is the problem of the impurities of these sulfur gases that give that smell too. And now that they have the biogas plants, they say that the situation have improved because they could not even open the window in summer. So, Tommaso, please go ahead. Now you have the microphone open. You can open it. you
Should be
want to.
open. Do you have problems, Tommaso?
Oh,
I'm
doesn't
rechecking
work?
the settings. I'm rechecking the settings.
Can you hear me now?
Yes, yes, yes.
Yes.
Oh, okay. Sorry, I don't know why. No, I wanted just to ask from the discussion you were having. I think that one of the reasons that actually the citizens actually complain, well, there are several reasons, of course, but one is that when the plant starts working, the local production and, let's say, treatment of the wastes is not enough to keep the plant on. So they have to import more, let's say, more waste from other regions, for example. And so it will become like a local a local well of wastes. And of course, it will reduce the overall net greenhouse gas emissions, but it will also create places where a lot of wastes will accumulate. I'm not saying I agree or don't agree. I'm just saying what I've read and what I've so that's probably another of the concern of the local population, I would say, more than converting the local wastes into some usable product and actually marketable product. But it's because also you are importing a lot of wastes from other regions because the plant is working and it needs to keep having the inputs, let's say. Just that. Thank you. And thank you very much to both of you for the explanation. Really interesting.
Thank you to you, Tommaso, for your participation. We have only 1 minute left, so if anyone has a question, a final question.
Okay. Okay. Thank you very much. We still have the closing of the webinar. I have a couple of slides to show. Alessandro, go on.
No, I just wanted to tell something to the person that observed that for small towns, maybe the door-to-door collection is too costly, too expensive to be implemented. I want to say what was one of my focus points in my speech, that don't consider the common speech. You have to verify your territory, your solution, because it's not universally true that door-to-door collection is more expensive than other forms. In our case, for example, we calculated the loss of the tax income based on the distance from the bin for the open territory, and it was more costly than the door-to-door collection. So I repeat, every solution, every project should be tailored, and don't believe the common speech that something is good, something is bad, something is expensive, and something else is less expensive.
Thank you, Alessandro, for this interesting final comment. So basically, if I can still 5 last minutes from your time. Sorry, because this was not the presentation. Yeah, I think that's the one. In any case, well, the speakers, if you have further questions or comments, as I said, the slides will be shared. You will have also the reference of their projects. So I'm sure they will be happy to answer you if you want to contact them. So basically, well, I hope it has been useful to review all these insights on organic waste, to see these examples of technologies, these lessons learned, these barriers, and how to mitigate them. I want to share some next steps of our project. So we will develop some new tools after summer. So policy recommendations for local administrations, some guidelines. So we recommend you to stay tuned at our social networks of the CCRI. CCRI website and LinkedIn. And also we will hold our final event on the 28th of October with the Circular Week. You are invited to come. And I also wanted to say that there are still 4 webinars left from our series. So in this month. So the first one is ours, sorry. So we have 3 left on, from innovation to trust, reducing uncertainty to circular value chains, from SETEC, governance and contracting with outsourced wasted operators by FILSE. These are partners from our consortiums, and from circular economy roadmap to operational program. You have more information at the calendar also of the CCRI website. And we have also another webinar organized by Cabelote. I take the occasion to also promote it, related also to bioeconomy, designing an effective stakeholder engagement strategy for the bioeconomy, very related with all what we were just discussing. And finally, we please ask you if you could help us improve by answering this survey. You can scan this code, or you can go to the link. You can go to the link directly through my screen, but also I will put it in the chat.
Can you, Noemi, or should
Yes.
I write?
Yeah, I have it at hand. And
Okay.
yes, and that would be it. So again, thanks a lot, especially thanks to all the speakers for your contribution. Thanks also to Aran and my colleagues supporting the webinar, and of course to all the attendants. So we remain available for any question at our general emails. Thank you very much.
Bye-bye. Just if anyone has another question, just to remind that you can share it with us, any other question, and we can send it to the speakers if any question arises.
Exactly.
I think you can finish. Noemi.
Just put here my email.
Okay.
Okay, thank you very much.
Bye-bye.
I stop sharing. Bye, good afternoon.
Bye-bye, thank you.